Okay, now the average rate for the f of x is 1 over the square root of x, which has kind of gotten crowded out, we saw is equal to this. Now, that's in yellow. In green, we start with the simplification of this expression. Borrowing what we saw over here, we get this. Borrowing what we saw up here, we get this. And then it all simplifies considerably. And I'm kind of leaving the last step. And I'll write out what that is in a minute. So, how do we borrow? Well, we just use the idea. We've got something here, which is a difference of two things that involve a square root. What I want to do is I want to put these over a common denominator. Okay, the common denominator, just like we did a common denominator here, when it was an x in the denominator, it's going to be this times this. Okay, that should be pretty obvious. And if you work out the steps of that, you see that to get the first term, we have to multiply by square root of x over square root of x, which will give us a square root of x in the numerator. And here by the square root of x plus delta x both times, which will give us a square root of x plus delta x in the numerator. And then the product of our denominators. So this goes over common denominator and gives us this, and that should be fairly straightforward. And then that's still all divided by delta x. Now, dividing this by delta x is the same as multiplying by 1 over delta x. The delta x is not going to divide into any factor, any common factor of the numerator. So we're just going to put the delta x in the denominator, and this gives us this much of this expression. Let's ignore this part for a minute until we see why we want to do it. So let's just focus on this part of the expression before the asterisk. Okay, make sure we see why this is equal to this. We've just written the division by delta x as reciprocal delta x and incorporated that in our fraction, and that's going to end up in the denominator there. Make sure you understand that. Okay, now what do? Well, we do something similar to what we did up here. We've got a square root minus a square root. If we do a square root plus a square root, we can again use the fact that a minus b times a plus b is a squared minus b squared. And that's, of course, we're going to have to multiply by that in numerator and denominator. Now, you should work out what you get by that, and then show that what you get, I'll put a couple of dots there, will end up equaling, and let me be careful when I write this down, is going to be delta x, and it's going to be negative delta x and a positive delta x. It's late in the day. I want to be sure I get my coefficients right. You're going to have an x minus the quantity x plus delta x, very similar to what you had here. So you're just going to end up with a delta x in the numerator. In the denominator, you're going to have a delta x. And then you're going to have some other stuff. Okay, I'm not going to write out what that is. I mean, I can see what it is, just all this stuff. But you should write that out. And be careful about the fact that you've got a binomial here. Okay? So the algebra is a little bit ugly, a little bit complicated, but not too bad. Should be manageable. Okay, what about the sine of x plus delta x over delta x? I'll give you a hint, see if you can write this out before you see it again. We can use the sine of alpha plus beta formula, which is easily enough derived if you use Euler's identity, a little harder if you try to do it with triangles. But sine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. See if you can use that to begin simplifying this expression. You're probably not going to get too far until we start taking limits. The thing doesn't simplify very much. But as soon as we start taking limits, as delta x approaches 0, and you should know that that's where we're heading, things simplify out very nicely. So, see what you can do with that.